Hi, Assalamualaikum and selamat sejahtera. Today, we are from Group 2 for subject Microprocessor and Microcontroller BNR21703 from Section 1 and Section 2. We'll present about project that we have done. My group member are Lu Jianming, metric number AN 190181. Second, Muhammad Alif bin Ismail Rani, metric number CN200027, and me, Noranisha Sazlin binti Irwan, CN190175. Project description for this project is focusing for microprocessor and microcontroller subject, and will seek to develop student skill in every topic in this subject. We use the PIC 16F877A as a microcontroller. In an integrated system, a microcontroller is a small integrated circuit, which is IC, that controls specific operation. On a single chip, a typical microcontroller contains a processor, memory, and input or output. As we know, we provide suitable software to generate the simulation and encourage us to use it. Next, we need to include keyboard and interrupt concept for this project. The keyboard is used to interact with the 7 segment. This is through the 2 7-segment display of the microcontroller. Through the Proteus simulation program, we can predict whether the circuit will work. In addition, an interrupt service routine, which is ISR, is similar to a subroutine in that it contains code that it executes when the ISR is entered. After completing the ISR function, control will be transferred back to the main program. The use of the keyboard and the interrupt concept have several advantages, as it creates a faster response time for the user, and at the same time, it can reduce our energy and make it easier. Lastly, microcontroller-based applications usually have the following structure. It receives information for a keyboard and other device, and use as a set of algorithms to process it to produce an output that can be displayed on a 7-segment display or used to control other devices such as a LED.
Assalamualaikum, my name is Muhammad Alif and I will be presenting the programming flowchart. Okay, this is the first task, which is to show our group number 02. So from here, from start, then we select the band 1 at trace A, then move the 0110 to W register, and after that we'll move the W register to ADCON 1 register, and alright, and then we set the W register to 0. So after that, next is we move the 0 to W register, then move the W register to port C. This is to display the number 0 at port C. And next, we move the number 2 to W register, and then move the W register to port D. So this will come out with 02 at port C and port D. Right, and then that's the end for this first task. Next, this is the main program, which does not include any interrupt at all. Right, the goal is to display random number chosen by us, and then with different output for the 4 different input. So for the start, we set the delay counter at 225, and then count low at bank 0. Then from here we can see that we move the 0x0 to 3A, B, and C to set the output 1111 1100. This is because we choose we have to make the RB2 and RB3 as the output. Alright, then we set the RB0 to high, and we set the W register to 0. So alright, this is the next part is very fun because we have 4 different output, but programming is kind of same. Alright, this is 4 button For button 1 and button 3 will be the same, but with different output. Button 2 and button 4 will be the same also, but it will different from button 1 and button 3, and all of these will display in different output. So for button 1, when it's pressed, we will use the RB2. If RB2 become 1, then we will display number 2 and number 0. If button 2 is pressed, we will use RB3. If RB3 is 1, then we will display number 19 and number 0. So next, for button 3, when button 3 is pressed, we will use RB2. So from here we can see that button 3 and button 1 use the same RB. So, and button 2 and button 4 we use the same RB, which is RB3, RB1, RB2, button 1 and button 3. Okay. Next, for button 3, we will display number 8, 7, 20 and 00. For button 4, we'll display number 27, 19 and 75. That's the end. This is the end for our main program. Next is our ISR program, which is interrupt service routine. Right, next, this is the flowchart for the ISR. So first we declare a start, and then we declare the microchip. We use the PIC 63F778. Then we set the address to 0 and the origin at 04H, because the 00H already used by our main program. Then we select the location of trace B, and we set the RB0 to RB3 as our output, RB4 until RB7 as our input. After that, we move the value 0F to register W. So right now, LED 0 to LED 4 is always off when there is no interrupt. So we have to set the interrupt. Set the GIE to 1 and RBIE to 1 to enable the interrupt, and that's the end. Then for the interrupt process, we use port B. So from here, from top to bottom, we can see that RB7, we use RB7, RB6, 5 and RB4. If RB7 becomes 1, it will show blue, red and yellow LED will blink 3 times, but before that it will pause for a moment. All of this all this output will be the same. They all will pause a minute and then pause for a moment, and then they will do the task given. So for the RB6, if it's become 1, we show red and green LED will blink 3 times. If the RB6 is not 1, if it's 0, then we'll move to the RB5. RB5, if RB5 is 1, the blue and yellow LED will blink 3 times. If it's not, if RB5 is 0, we'll move to RB4. So RB4, if RB4 is 1, it will show green and yellow LED will blink 3 times. And then if it's 0, it will go to the end. And that's it for the programming flowchart. Next is our friend will show the simulation demo. Thank you very much.
A very good day to Dr. Aimi. My name is Lu Jianming, and I'm going to present for the part simulation demo. And this is the program circuit diagram. And first of all, when the program code is run, the display will have 02. This is because we are from group 2 and all the LED light is light up. And this program have 2 main sections, which are the keypad function and the interrupt service routine. So for the keypad functions, we have 4 buttons for the keypad, and each of them will display different set of number in this display. For example, when the button 1 is pressed, it will display 20, and when the button 2 is pressed, it will display 19 and 01. And the next section will be the interrupt service routine. So for the interruptions, the interruption will have the LED light blinking for 3 times with different LED light. For example, when the first interruption button is pressed, the blue, red and yellow light will blinking for 3 times. And for the second, the LED green and red will blinking for 3 times, and so on. So the special characteristics of the interruption is when the keypad number 3 is pressed and running, and at the same time we press the interruption button, the main program will be paused and simulate the interruptions first, and after the interruption it will continue its display of the keypad number. And that's the main idea of our program. And in short, if we apply this program in different situations and different program code, it can have different functions, for instance. Therefore, we can apply this program code and circuit diagram for different usage. And that's all from our presentations. Thank you.